If you Google AutoKit, you can find this getting started with the AutoKit web page. Getting started with the AutoKit in Python. And they introduce every details. Well, not really every function, but the most commonly used functions. So I made the code to find the atoms in the molecule in here. So you can take a look at here. If you're new to AutoKit, and this time we're going to use this part. I want to check similarity of the molecule using fingerprint. So it's quite easy. I calculate the fingerprint. So first I should have a smiles code and then read the smiles code and have a AutoKit mold. And then calculate the fingerprint and then check the similarity. So this is the code. I take this example code, and here I have 3 different smiles code and I can check similarity. So first I read and have a mold list and then calculate fingerprints and then compare the similarity between this and this first, which was 0.6. Here structure similarity is higher. If the similarity value is higher, then that means they are similar molecule. And when I compare this molecule and I run this code, which means I'm gonna compare this and this, and the result is 0.4 and 0.6. So when I use what was the fingerprint? I use this fingerprint, and when I compare the similarity with this fingerprint, it says this is much similar. But actually, how do we know that which similarity works well? Oh, well, there will be another way of similarity analysis, and well, different methods give different values. But how do we know which method is a good method for me for my task? For that, I believe you should have your own standard first. You should set a criteria that this structure and the other structure are similar, but the other one is not. In this case, I think these and these are much similar than this one because oxygen is covered by carbon. This one is also, but this one is oxygen is open to the outside. So I believe physical chemical property may be much similar between these rather than this. So if that's my criteria and my intuition, then this is not really a good way. So there's another way of doing the structure similarity calculation, and here I use Morgan fingerprint. If you use Morgan fingerprint, you can calculate fingerprint a little bit different way. So here it says it's 2, which means if this is a center atom, this is a distance 1 here, distance 2 will be this. So this distance is based on the bridge. Here bridge is chemical bond. So how many bonds should I go through? So here first and second. I should to reach here the shortest path is 1 and 2. So I need to cross 2 bridges. So that's why the distance is 2. And if I use this fingerprint, I get the fragment of the molecule based on this distance of 2. So this part will be my fragment. So if I calculate fingerprint, it converts structure into bit string like this, 0 1 1 0 0 0 0 0 and so forth. And each bit implies the presence of the molecule. So if 1 means presence of the fragment and 0 means absence of the fragment. And this Morgan fingerprint define molecular fragment based on the distance. So I can increase it like a 3 and 4. But if I increase it, I will have more unique fragments as molecular structures are getting more complex like this. So it's much difficult to find this pattern than this pattern. So this is how fingerprint works. And now I try with different fingerprint and calculate the similarity. And you see this time I get higher value in here. So in the previous code, this has a higher value, but when I change it, the fingerprint, this molecule were much similar. And this is going along with my uh, criteria of similar molecule. So I think this is better than the previous method. So that's how you decided which similarity method you're gonna use. And here I increase the topological distance, but still I have same value. It's simply because the example molecules were too simple. So if I take it, if this is the starting atom, 1 and 2, that's the distance. There's no 3 or 4. So distance 2 and distance 4 are actually the same. So I want to test it if how molecular similarity score has changed if the molecule is much more complex. So I take the complicated structure like this, and I decide to calculate the similarity. So here, this molecule and this molecule has this much similarity, while this molecule and this molecule has this much value. But you see they're actually quite similar. This part are same up to here. So this part are quite same. So you see, larger portion was overlapped. So these are quite similar. But for these, maybe this part is quite similar, and another part are not. So the larger portion was overlapped between these two. So that's why this molecule was considered as a much similar to this molecule. And what happened if I increase the topological distance from 2 to 4? Oh, before going into that, I just print this to show you how fingerprint looks like. And to calculate fingerprint, you need to use this one. Fingerprint as bit vect, and then use it to bit string. Then you're gonna have this fingerprint values. So you see very small number of 1, but mostly zeros. So this is quite sparse vector. But anyway, it's essential, quite efficient way of calculating molecular structure similarity. And now I have a 4 as a topological distance for this fingerprint. And in this case, values were changed. But still, this was much higher, like the same, like the result before. So we can check that the similarity was decreased. So in this case, it was 0.3 and now 0.2. And as molecular fragments get complexed, it's much harder to find that pattern in the structure, and presumably that's the reason for decrease of the structure similarity score. And now we're gonna run this to entire structure in the next video. So in this video, I just introduced how to calculate fingerprints and then measure the structure similarity using ArcticKit.